Just like with linear inequalities, where you can graph a boundary line and shade one side of the half plane or the other, you can also do something very similar to a quadratic inequality, which is like a quadratic equation. It does have an exponent of 2 in it, but it has an inequality sign instead of an equal sign. Since it's a quadratic inequality and has an exponent of 2, the boundary is going to be a parabola. So we will need to go and talk about how to graph the boundary line by using the 3-step process for graphing a parabola. And then we will go one step further and figure out where the shading occurs on that graph. So to graph y is greater than x squared plus 2x plus 1, the first thing we need to do is find the vertex. That's the first step in graphing our boundary, is find the vertex. And we find the vertex using negative b over 2a. That gives you the x value of the vertex. So on this inequality, our b value is the 2, so that means we will use negative 2 over 2 times the a value, and the a value is the number in front of the x squared, which would be the hidden 1, and negative 2 over 2 simplifies to negative 1. So the vertex has an x value of negative 1, and then to find the y value, we will plug in the negative 1 we just found into the original problem, and that gives us the y value. So that will be negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared is positive 1 minus 2 plus 1, and that gives us 0. So the vertex is located at negative 1, 0. So I go to my graph and I will place my vertex there. And then the second step is to identify the Y-intercept. Remember, the Y-intercept is the C value, and the C value in this case is the 1 at the end of the problem. So the C value is 1, that is on the Y-axis, so I can go ahead and plot that. And then we use what we affectionately call the 1-3-5 rule. And remember, the 1-3-5 rule is taken times the a value, and in this case the a value is 1, and when you take 1-3-5 times 1, you still get 1-3-5. So we will start at the vertex, and from the vertex we will go out 1 both directions and up 1, and notice that we hit the y-intercept, so that's a pretty good indication that we're correct. And then we'll go out 1 and up 3. So again, out 1 and up 3. And then out 1 and up 5. Out 1 and up 5, both directions. And then we will draw our parabola. When we draw the parabola, notice that in the original problem it used a greater than sign, but it was not equal to. So just like with linear inequalities, when that occurs, we're going to use a dotted boundary line. So boundary line will be just like this, dotted. And then we got to figure out where the shading is. With a linear inequality, shading occurs on either like the left side or the right side of the boundary line, or we might refer to it as being the top or the bottom of the boundary line. But with a parabola, our sides are really inside. We talk about it in terms of being inside, which would be between the parabola lines, parabola curves, I should say, or outside. And outside would be basically everything all the way around it. So we've got to figure out exactly where the shading occurs. And we still do that by using a test point. And remember, a great test point is 0, 0. So going back to the original problem, we're going to test 0, 0. Again, only if 0, 0 is not on the boundary. If it is on the boundary, you got to pick something else. So replace the x's and y's with zeros. So is 0 greater than 0 squared plus 2 times 0 plus 1? Is that true or false? Well, 0 squared is 0. 2 times 0 is 0. So that gives us 0 greater than 1. Is that true or false? Well, that is false. That is a big no. Well, 0, 0 was right here. I'll highlight it with a point here. Just barely on the outside of the boundary. Well, that was a no. Well, since that's a no, what we're going to do is we're going to shade inside, because since 0, 0 was outside of our boundary area, we're going to shade inside. So I'll color that in. And remember, that means that anything that's inside of the shaded area is a solution to the original problem. If it's on the dotted line, it is not a solution. Now, if it was on a solid curve, it would be a solution, but being on a dotted curve boundary, a boundary of any type, means it's not a solution. So let's try another one. This one is y is greater than or equal to negative x squared plus 4x plus 1. So again, we're going to find a boundary. It's going to be a parabola, so let's use x equals negative b over 2a to do that, to find that boundary. And so negative b, that's going to be negative 4 over 2, and a is negative 1, which is going to give us an x value of negative 4 over negative 2, which is equal to 2. So the vertex is going to be located at 2. And then what is going to be the y value? We'll figure that out by plugging the 2 in for x. Now, this is a tricky part. Notice that there is a negative already part of the original problem, which means you're only plugging in 2 in for the x. That's going to be important on the next line. Yep, I guess I need to replace that x as well with a 2. So it's negative 2 squared, but the negative was a part of the original problem. So you're only squaring the 2, which is 4, but it remains negative because the exponent of 2 is not affected in the original problem, is not affecting the minus sign, is not affecting the negative sign. So negative 2 squared equals negative 4. Plus 4 times 2, that's going to be 8 plus 1. And when you add that together, you get 5. So the vertex is located at 2, 5. So over 2 up 5, we'll place a point there. And then the second step is to use the c value to find the y-intercept. And the c value is a 1. So we'll place a point on the y-intercept at 1. And then we'll do the 1, 3, 5 rule. We'll take it times the a value. The a value is negative 1. It's the number in front of the x squared term. So when you take 1, 3, 5 times negative 1, you get negative 1, negative 3, negative 5. And that means that we will be going out 1 and down each one of those numbers. So we'll go out 1 each direction and down 1. And then from those points, we'll go out 1 each direction and down 3, which hits us on the y-intercept, so that's a good sign. And then we'll go out 1 and down 5. 1, 2, 3, 4, 5. And out 1, down 1, 2, 3, 4, 5. So we will use a solid boundary line this time because it's greater than or equal to. So this time it'll be solid. So I draw my best curve through there. And then we got to figure out where to shade. So we're going to do a test point. We can still test 0, 0 because the boundary barely misses 0, 0. It's a little bit above it and a little bit to the left. So we'll do negative 0 squared plus 4 times 0 plus 1 and see if 0 is greater than or equal to that. So is 0 greater than or equal to 0 plus 0 plus 1? That's a no. 0 is not greater than 0 plus 0 plus 1. So since it's a no, but 0, 0 is inside the parabola, we're going to shade outside of the parabola. So there's going to be lots of shading involved on this one, all the way around it. The one thing I do want you to make sure that you realize is do not shade underneath the parabola. That is a big no, because the parabola continues to go on forever and ever and ever. Just because I ended my parabolas at the arrows doesn't mean it doesn't continue on this direction forever and ever and ever. So I'm not going to shade underneath the parabola. I'm only going to shade all the way around it. So I would shade all the way around it like that. That's what it should look like shaded.